Testing, Kyoko, can you hear me loud?
Yeah.
All right, very good. Okay, Kyoko, we'll wait for 1 minute and then we're gonna start, yeah? Okay, Kyoko, come, let us start, yeah? We were talking about the weakness of your calculator, right? So there are two basic weakness. I want you to remember them so that you can use calculator correctly, right? Now, I want to summarize that weakness first before I show you the way without calculator. Now, what do you think is the weakness of your calculator for triangle? Before we start, Ainesh, can you hear me loud and clear?
Yes.
Right. We started for 2 minutes earlier, so I'm just discussing the weakness of the calculator. Okay. So I'm asking you and Kyoko, based on first session, there are two weaknesses of calculator. We have to be very clear about this. What are the two weaknesses? Kyoko, maybe you can name one, and then Ainesh, you can name another one. Kyoko? Okay, now I would like to remind you, Kyoko and Ainesh, you go to page 2 of the Jamboard, yeah? Page 2 of the Jamboard.
It's
Yes.
based off last lesson, then.
I'm sorry, Ainesh, you were saying? Sorry.
I mean, not based off last lesson, but I know that it can't detect PEMDAS. Like if you put in a whole PEMDAS equation, it can't detect it.
You cannot detect what? Sorry, you cannot detect what? Panda?
No, I think because of my voice, you can't. Yeah, I just typed it out.
Where do you? Oh, PEMDAS. Okay, I'm not sure what PEMDAS is. What is PEMDAS?
Oh, you know the bracket order, like order of operations, like brackets and multiplication, division.
Are you saying that if you bracket it properly, the calculator is still wrong? Or is that what you're saying? Sorry.
No, so like 2 plus 3 multiplied by 4 times 2.
Oh, you're saying that you have to bracket it properly. If not, the calculator will give you a wrong answer lah.
No.
What?
Basically, in an order of operations, you do brackets first, and then you multiply
Correct.
and divide.
Yeah.
The computer can't do that.
The calculator prioritizes not the brackets, prioritize something else.
It goes from left to right by multiplication first. It doesn't.
Yeah. So the human agreement somehow is different from how the calculator do it in terms of bracket priority lah.
Yeah.
Okay, totally agree with that. I was exploring the two weaknesses in trigonometry law. So first session. So back to the first session. Obviously, the PEMDA will play a role here also. I agree, but I'm aiming for two more lah. What are the weaknesses? I want you to go back to page 2, people. Page 2 in Jamboard. Tell me if you are here. Hi, page 2. Are you in page 2, people?
Yeah.
Okay, good. Ainesh?
Yeah.
Okay, good. Now, while setting up your video, be quick, Now, this was the first weakness. Okay, try to remember, Kyoko, what happened here? What was the weakness of the calculator?
The angle isn't accurate.
Although that's not the proper phrasing, I will rephrase for you. The calculator will give you an answer. The answer is not wrong. However, the answer is not what the question wants. The reason is because there are multiple answers. And the calculator only gives you one. Usually not what the question wants. Because the question maker knows. The question maker knows what the calculator will give you, and he will purposely avoid that. So the calculator has a weakness. Okay, it's a limitation. Okay, is that roughly what you're thinking, Kyoko?
Yeah.
All right. Be aware this always happens in trigonometry. Okay, and the question maker will definitely know and use that. Yeah, just be very clear about it. Okay, Ainesh, you're clear? That's the first weakness.
Yeah.
Okay, what is the second weakness, Ainesh, if you remember?
I don't know.
Right, go to page 3. Now, Kyoko, Ainesh, shut up your video, yeah? Kyoko, show me your working for page 3. That's a very good illustration, right? Show me your working for page 3 just now. Very good. I'm going to copy that. Yeah. Oh, no. Okay. Oh, no. I see. Okay. So in page 3, I just pasted Kyoko's working. I understand that this was also your result, yeah? Ainesh, this was, yeah? Okay. Now this is the second weakness. This. Remember, we're using the full decimal point. We were using the full decimal point here as you have follow me. Great, good job. You still end up with what you call an ugly number. That didn't happen in the first question. That happened in this second question. This is the second weakness of the calculator. The calculator will sometimes cannot simply give you a nice number when the question demands it. Those are the two weaknesses of calculator in trigonometry. Kyoko, what is the first one?
Can I?
Yes.
Oh, you can just set it to 3s or something, and then it'll.
And then you will what? This become a nice number, really?
It'll give it to 3s.
That is not solving the problem at all. That's not what I mean by a nice number, or rather, sorry, that's not what they mean by a nice number. They want an exact number. And if you give them this, you're basically giving them not an exact number. You round it off, man. Correct.
Yeah.
Then that's it. Then you only lose 1 mark. I mean, to be fair, you only lose 1 mark. It's not exact, but it illustrates the weakness of the calculator. I have to show you a method to find the exact number lah. I mean, that's what I have to do lah. But calculator cannot do that.
Yeah.
Clear, yeah? Okay, Ines, you mentioned the second weakness. What's the first weakness, Kyoko?
The calculator gives multiple answers.
No, the calculator cannot give multiple answers. Sorry, cannot. The calculator gives one answer out of the multiple, and usually not what the question wants. Usually. Okay, yeah, right. So before we continue, yeah, I'm just going to greet Aryan. Aryan, can you hear me loud and clear?
Yeah.
Okay. Now, Aryan, this is what I say to Noah and Michael. Unless there is an urgent topic, today we're going to revise our trigonometry lah, right? In preparation for prelim. Prelim is like 1.5 months from now lah, usually.
Yeah.
Okay, right? So unless you have an urgent topic to discuss, we just refresh our trigonometry. Okay.
Yeah.
Okay. So Aryan, I invited you to the Jamboard already. They already did page 2, 4, and 5. Those are the two trigonometry, and then they're going to do further question again, still trigonometry, right? So unless you want a different topic, you're just gonna do these questions as a refresh, okay? Just to make sure they are okay. Again?
Yeah.
All right. Noah and Michael, I see you here. Noah and Michael, right? Can you hear me?
Yeah.
Right. So Noah and Michael, you should start at page 6 lah. Still the similar type of trigonometry, right? Still, just to make sure that you're there. A bit more difficult. I just want to say that. A bit more difficult. And then for you, Noah, in page 9, I prepare for you 2 integration questions. They are definitely not a story, but a bit longer. I confirm that I don't think there's a story word problem kind of integration question. I don't think there is. So this is just the longest I could find. Okay, and they are not the easiest also. So that might be a good practice for you. Okay. Okay, yeah. Michael and Noah, you start at page 6, right? Page 6, and Aryan, you'll stay at page 2. Okay, I would like to see your video. Now, Ines, are you ready with your video? I really need to follow what you're working,
Oh.
Right? Your video, please.
Yeah, give me a moment.
Sure.
I need to go get it. Yeah.
Michael and Noah, I'm going to shift the page to 7. You don't have to do anything. You don't have to do anything. You'll just shift together with it, right? Okay. Kyoko and Ines, move with me to page 3, right? It's the same question. Okay, Noah, page 7, Mike, page 7, Aryan, page 2, yeah? Okay, Kyoko, we're just waiting for Ines.
I cannot see the question.
Page 2. You mean it's too messy? Is it?
No, like I can't. Like, it isn't loading.
It isn't loading. All right. I think that tends to happen. So I'm just going to send you the first question first, Just right. Then wait for your Jamboard to load, It's the new Jamboard, yeah. It's a new Jamboard called Final Holiday Tuition, Aryan, yeah. Sorry, wait, where is it? What's happening? Okay, I'm sending you the question. So treat this as a warm-up question, Aryan. The first 3 questions are warm-up. Okay, I send you to WhatsApp already. Okay, I'm still not seeing Ines. Okay. Okay, landscape, please. All right, very good. Okay. Okay, Ainesh, good, yeah? So Ainesh, we're at page 3. Are you there with me?
I didn't realize it was me. Yeah.
All right, so same question, yeah? But now I'm demonstrating the method without calculator, right? It will solve 2 weaknesses. The first weakness is the multiple answer problem. The second weakness is the not so nice number, right? Now I have with me, for comparison purposes, sine, cosine, and tangent graph. So I'm just going to separate them. 1, 2, 3, 4. You notice that I draw sine, cosine, and tangent graphs a lot. When you're more independent, you will be doing this a lot also. But now, in the sake of time, I'm going to just do that. Now, back to the graph. Notice Kyoko and Ainesh. Sine does have mirror images here and does have mirror image here. You understand what I'm saying? This is very visual. Ainesh, clear?
Yeah.
Kyoko, clear?
Sorry, which page?
Page 3, please. Are you at page 3? Okay, very good. Now one more time, Kyoko. This is the sine graph.
Yeah.
Sine graph do have mirror image. This is mirror image. This is also mirror image. Okay? You notice that, right? Cosine also just differently. This is mirror image and this is mirror image. Clear, yeah? Ainesh, yeah? Right. Furthermore, we can see the quadrant 1, 2, 3, 4 quite easily, right? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. That's just, 0 to 90, 90 to 180, 180 to 270, 270 to 360. You just give a fancy name called quadrant. One more time, quadrant 1, you will call acute law. Quadrant 2, you'll call obtuse law. Quadrant 3 and 4, you'll call reflex law. I mean, just the same thing. Now, notice one thing. Ainesh and Kyoko. For quadrant 1, sine, cosine, and tangent, they are positive. Do you notice that? Positive, positive, positive. Do you understand this? Very visual. Ainesh, can?
Yeah.
Yeah, clear. Now, things start to be different in quadrant 2 and quadrant 3 and quadrant 4. Okay. For quadrant 2, the sign is, what is it, Kyoko?
Positive.
Positive, very good. However, Ainesh, for cosine and tangent, it is negative. Negative, yeah? So clear, yeah? Positive, clear. Now, Ainesh, let's look at the comparison for quadrant 3. Negative, negative. What happens in quadrant 3, Ainesh? Look at it.
Negative, negative, positive.
Right, so I'll make it very clear. Tangent is positive, but the other two is negative. Finally, Kyoko, for quadrant 4, what's the observation?
Positive, negative.
Right, negative. So I want to summarize it this way. For quadrant 1, everybody positive. This is the source of the easiness of quadrant 1, and that's why they will avoid it. Right? For quadrant 2, 3, or 4, they take turn. No? Quadrant 2, only sine is positive. Quadrant 3, only tangent. And quadrant 4, only cosine. Some people memorize this, but I will tend to say, just look at the graph. It's obvious what. Okay, so I won't behave like your teacher for now. Your teacher will say immediately memorize this without the graph. I will say the graph is the proof. You don't have to memorize. So far, so good, Kyoko and Ainesh? Yeah, now I will now represent this 3 graph into a simpler form. This is what your teacher will do. You would agree with me, this is positive x-axis, positive y-axis, negative y-axis, negative x-axis. Nothing complicated, you know already. Kyoko and Ainesh, clear, yeah? Can, yeah? 0 degree, I will call this quadrant 1, right? So that means this is your 90 degree. This means this is your 180 degree. This means this is your 270 degree. and therefore this is 0 degree or 360 degree. I will go like that. At this point, I ask first slowly, any problem or not with what I'm doing? Any problem? No, yeah, good. Now, give me an angle which is at quadrant 2, Kyoko.
120.
Okay, 120. Now watch, people. I'm going to draw 120. Yeah, so like that. No? Now, let this be clear first, people. Even though 120 is here, my sine cosine triangle must be here. This is one of the weird things. Just bear with me for now. Just bear with me for now. Bear with me for now. Even though this is the 120, I obviously cannot draw a 90-degree triangle here. I have to draw it here. That's just how it is. Can ya? Yeah. So this is now my angle. My angle will be presented by this theta, right? This will be my opposite. This will be my adjacent. This will be my hypotenuse. Now, theta, sine. What is sine, Ainesh? Sine will be something over something, right?
Yeah.
What is it?
Adjacent over hypotenuse.
Oh, no. So, a bit of memorization. Toka, so. Opposite over hypotenuse. Sine.
Oh.
Opposite,
Is it adjacent opposite?
No. Sine. Tokaso, ma. So, sorry. Did you remember as Sokatoa or Tokaso? Which one?
No, I don't know anything like that.
Okay. At least they have a device to memorize this, I suppose. I'll give it to you. Sokatoa. Sine is opposite over hypotenuse. Solo. Okay. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Right? That's their memory device like they give you.
I usually refer to it as length, base, and then hypotenuse.
Fair, but the length should be what you call the opposite. The base should be what you call the adjacent and the hypotenuse, right? That's fair. I'm going to use your method, no problem. Length, base, as long as we are talking about the same thing. Yeah? Now, the sine is opposite or length over hypotenuse. So this guy over this guy. Now, do you notice that the opposite is positive, meaning a positive y-axis, correct? Positive, correct? Notice that? Okay, the base, however, is negative in a way that is a negative x-axis. Do you notice that? Okay, negative, huh? Negative. And the hypotenuse is neutral. Neutral means it is always positive. The reason is very simple, because hypotenuse is made out of squares, right? Square, and then you will always be positive. That's just how Pythagoras works. Hypotenuse is always positive. Okay, now I'm saying this, meaning again, this guy will be positive, this guy will be negative. Can I accept that for now? Then, now I will show you that this triangle represents all the quadrant 2. What do I mean by that? This triangle shows you that the sign is positive over positive. So, positive, look. The triangle also show you that the cosine is this guy over that guy, correct? So it's negative over positive. Negative, no? The triangle also show you that tangent is this guy over this guy. Wait, negative also, no? Do you understand what I just said? Can I accept Kyoko? Yeah? How about you, Ainesh? Yeah. Now I'm going to use the triangle immediately in the question. Tangent A minus 3 over 4 is an obtuse angle. You would agree with me? We'll be dealing with quadrant 2 obtuse angle. Now look at what I do. I will write tangent A equals to, look, 3 over minus 4 instead of minus 3 over 4. Pet dot. Observe one more time. I'm writing tangent A as 3 over minus 4. The reason is very simple. This is your positive 3, and here is your negative 4. Do you understand what I just did? Do you understand what I just did?
Somewhat.
Okay, somewhat. That's okay. Kyoko can? Kyoko can?
Somewhat. Also.
Somewhat. Somewhat is fine. Now, watch what I do, yeah? Watch what I do. I promise you that this is a non-calculator method, right? So once you get through all the basics, you'll be fine. Now, for hypotenuse, find for me first. If the opposite is 3, the adjacent is 4, using Pythagoras, the hypotenuse is actually very easy. What is it, Kyoko?
5.
Yeah, positive 5. Ainesh, would you agree? We usually know the Pythagoras 3, 4, 5. Okay?
Yeah.
Right. Now watch out. Watch. All the working is done. Now it is now super easy to write down sine A and cosine A without calculator. Kyoko, using the triangle, tell me what is sine A? Sine A is opposite over adjacent, right? So plus 3 over plus 5, correct? So positive look, 3 over 5, right? What is cosine using the triangle, Ainesh?
Cosine using the triangle.
Yeah. So you're saying that cosine is like the base, right? The base over the hypotenuse, correct? Okay, so what would that be?
Minus 4 by 5?
Plus 5, yes, correct. And that will be equal to minus 4 over 5.
Yeah.
Okay, and we are done. Sine A and cosine A will be totally what you'll be using anyway. For example, in secant A, secant A is 1 over cosine A. Done, no? Minus 5 over 4. Okay, we successfully found sine A and cosine A with all the proper sign, considering the graph, blah, 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 without even finding A. Without even finding A. We don't know what is A. The moment we find A, we use calculator. This is the super non-calculator method. I don't even care what is A. My sign will be correct. We bypass the calculator totally, therefore we bypass the weakness of the calculator. That is basically what this method means. Okay. Do you understand roughly?
Yeah.
Yeah, Ainesh, can?
Yeah.
All right. I'm going to repeat that for the B. I'm going to repeat that for the B. And then just going to repeat that for the B. Doing the thing, yeah, like that, like that. This is 0 degree, right? Okay, positive, positive, negative, negative. He told us that B is a reflex angle. Reflex means either quadrant 3 or quadrant 4. According to the graph, my cosine is quadrant 3 or quadrant 4. Look at it. Quadrant 3 or quadrant 4?
Quadrant 3.
No, 4. But why? Because cosine B is positive. Then follow.
I thought that was minus.
Oh, correct. If it is negative, then it will be quadrant 3. You are correct. But this time it's quadrant 4. Now, that means you understand what the question is trying to say. Question is hinting you. Quadrant 4. So what do I do in response to that? I bypass the calculator, right? Remember? So I will do this. This is just my random angle to represent B. And then I'll write something very interesting. Observe. I do note that B is 15 over 17. Now, The 17 will be the hypotenuse and the 15 will be this. It is of course positive. Am I making any sense here?
Yeah.
Ainesh can? Kyoko can? Okay. Making any sense? No, Kyoko, sorry. Yes or no?
No.
All right. Now I will go and find this guy lah. Now finding this guy does require calculator. So a bit, I'm just saying, oh, actually we're just still using calculator, right? But not for the sine cosine. So just use your Pythagoras and tell me what this number is. Use your calculator with Pythagoras. You still have to use it, huh? Unless you memorize everything already, right? Definitely not recommended. So Ainesh, use your calculator just to find this length, okay? Using your Pythagoras, please.
Okay. Eight.
Right, 8. Yes, Kyoko, 8 also.
Yeah.
However, I shall write -8, not 8. Of course, your calculator will give you 8, of course, but I will write -8. Do you know why? Minus y-axis, can? -8, can? Can, yeah? Would that be okay? Ainesh and Kyoko?
Yeah.
Right. Okay, now you have your cosine B given by the question. Now let's find sine B and let's find tangent B. Ainesh, what is sine B?
Sine B is -8 by 17.
Very good. And that is according to the graph. Hey, wait, sine is supposed to be a -1. There you go. Tangent B, Kyoko. Tangent B, Kyoko.
Over -8.
Sorry, something over, what? What over what?
15 over -8.
No, no. Opposite over adjacent. Opposite of the angle. Opposite over adjacent. What is it?
Oh, okay. -8 over 15.
Okay. And that is also correct considering the graph. Wait, it is supposed to be negative. I have bypassed the calculator in terms of trigonometry. I will still need it for Pythagoras. Okay, correct. Okay, so I have all this, and this is what I need for part 2. I will especially need this guy, but that's it. I'm just showing that it's very easy.
Teacher,
Yes, Aryan?
can I have the second question?
Is your Jamboard still in error?
Yeah,
Oh my goodness. Right. Okay.
I've tried reading it a few times, but still I can't see anything.
All right. Okay. So I'll do that. Now, Keiko and Ainesh, we have to get this well and done. We're going very slow. When you're ready, I will erase the answer, the new method I did, and then you're going to do it by yourself. Okay? Tell me when you are ready. Tell me when you're ready. Better ask questions before I erase.
Why are you erasing?
I am erasing the page 3, the answer, so that you can repeat what I'm doing. That means this will test you whether you kind of understand or not. That makes sense? Right. So only when you're ready, then I erase. Only when you're ready. Right? I'm asking you to do the method which bypasses the calculator, which is called the triangle method. Okay, tell me when you're ready. Yeah, Aryan, are you stuck somehow?
Sorry?
Are you stuck? No, right?
No.
You're negative and yeah. Your answer is actually correct. Very good. Yeah. Michael, are you stuck currently? Any question, Mike?
Is page 8, question 1, sketching, is the
Yeah. Yes.
so is this y equals to 3 cosine 2x? I know how to draw
Yeah.
that, but then there's the y equals to 2 minus 8 over 3 pi, basically. Is that a line?
Right. So you're talking about this guy first, right? I think
Yeah.
this guy first. So this guy is definitely a line. If you rearrange, right? If you rearrange, then it looks like a line with a very weird M lah, with a very weird M lah.
Yeah.
Correct? The M will make a lot of sense in your graph. I'm saying that this M is meant to make your life easier, not harder. I can guarantee you that. If you don't
Okay.
understand, that's what we learn. So yes, you're supposed to draw this line. You are supposed to draw this line. You are absolutely correct. Okay. Yeah. So draw this line first. Let's see how you handle the M. I can guarantee you one more time, it is actually meant to make your life easier, not harder. This is something that you should try to understand for this question. Then okay for exam. Kyoko, are you ready? If you're not ready, just say.
Oh, God, can I also go to the restroom?
Yes, please. Kyoko, are you ready? Kyoko, are you ready?
Ready.
All right. Ainesh, are you ready?
Yeah.
All right. I'm going to erase, yeah? I'm going to erase, and then please try it on your paper, and I will guide you as you try. Okay, erasing. This is just to remind you, yeah? Right, so both of you, Kyoko and Ainesh, you should be starting with the axis. The triangle method totally depends on this axis. Ainesh, are you ready to start?
Yeah.
Noah, you don't seem to be stuck. Are you okay?
For page 8, which is question 3, is that what graph is it?
Which graph? Which one are you talking about?
Y
Which one?
equals a line 3 cosine 2x line.
Oh. You're saying that you do not know what the line means, right? That's what you're saying. Okay. For now, I'm going to ask you to ignore that because turns out that is, I think, taken out of your syllabus for your year.
Okay.
Right. So I'm going to ignore that. I'm just ask you to ignore that also. For now, it's fine. Right. The line, however, should be not ignored. Okay. The other guy. Okay. Okay, Aryan, you're supposed to sketch that graph, I'm not sure why you're trying to find X there, yeah? I'm very confused right now. What you want to revise is that this question is a totally graphing question. They even say state, Do you understand what state means? State. The process of finding the answer, they don't care about your working. That means you still do something. You can use your method, but I think that will be unnecessarily difficult. I feel. Okay. They don't care about your method. Oh, okay. See, you did it correctly. Good. Okay. I want to see your graphing. Yeah, that's the most important part. Okay, Kyoko, I think your details are fine. Good. Okay, Ainesh, I'm following you. So from this triangle, Kyoko, you are supposed to be able to find anything that you want, really anything. Your working is done. You have to reap the benefit. For example, secant A, that means you require 1 over cosine A. From the triangle, you can find cosine A extremely easily by right. Right. Aryan, are you okay with the period?
Yeah.
Okay. Kyoko, are you stuck?
Remember the Sokato.
You can write down the Sokato. I mean, that's you can just write down to make your life easier, right? Right. I think better. I think better. It is memorization. So right? Then you know what's cosine, and then cosine is adjacent. Oh, okay, that helps a lot, right? It helps a lot. Ainesh, I would like to remind you that the 4 is a minus, not a plus.
Oh.
Very important. That's what we're looking for here.
The
Right.
4 minus. Why isn't the 3 a minus?
Because the 3 is y-axis plus, going up. If that makes sense, there's a reason for it.
That doesn't make sense.
What? Okay, so regarding the axis, right? Regarding the axis, we're drawing a quadrant 2. So this 3 is basically your y-axis, correct? But this is y-axis on the positive side, positive 3, right? But your 4 is the x-axis on the negative side, correct? Like let me put it another way. You will call this coordinate what? It's not a coordinate, but if you want to call it a coordinate, what coordinate will you call this point? Let's say what would you call it? Ainesh?
Yeah?
Can you hear me? Can you hear me?
Yeah.
What would you call this coordinate? If this is a point, let's say this is a point. What is the coordinate?
Minus 4, 3.
You see my point?
Oh, okay.
You see my point? That's what it means. Nothing new. Nothing new.
Yeah.
Okay, something like that. Something like that. That's why we call that negative 4. Oh, just like the coordinate. Something like that.
Yeah, that's got you.
And it works with the rest though, so easy peasy lah. The rest, if you get this one, you got it. Okay, so Kyoko, we found the answer while.
What do I need to find?
You look at the question and you say, hey, secant A. I told you secant A is a memorization. It's 1 over cosine A, correct? So that means you need cosine A. So can you find cosine A from the triangle? By right, you are supposed to be able to do that very, very easily because your setup is perfect. You got your setup already. So what's cosine A according to the triangle?
Cosine A is.
Remember your memorization, yeah, like base length, blah, blah, blah. Minus 4 over 5. I totally agree with you. You are correct. So your secant A will be?
5 by minus 4.
And you are correct. That this is the method which bypasses the calculator. Therefore, bypasses the weakness of the calculator.
Okay.
Right? Now do for B. B is slightly harder. It's a good practice. Then you got it lah. Michael, are you back? Just checking. Okay. Noah, you okay? Noah, you okay?
Yeah.
All right. Now, Aryan, I think your part 2 is wrong, I think you're not getting it, I think you're not getting this question. You're not getting this question. Your part 2 answer is, what is it?
360.
No. Oh. Because you memorized the period of the tangent is 180. Oh, then I don't blame you. No, never mind. No, that means you're correct. I'm so sorry. That means you're correct. That means, sorry. Just want to. Okay, part 3 also you're correct. So part 4. Part 4 is the main thing, is the sketch. Are you rusty with your sketch?
Yeah, kind of.
Practice it. That's the biggest mark. And this whole question is a sketch question anyway. So let me see. Do it the way I teach you lah, and let me revise with you if you can. Now, Ainesh, for the second guy, you use the same axis, no problem there. However, you have to put the 15 and the 17 properly lah. Right. Now for you, Kyoko, I think you put the 17 and the 15 correctly, but the 8 you have a problem. What's the problem with 8? I think you put the 15 and 17 correctly, Ainesh, I think. Then you use the calculator. Okay, good, Kyoko. Good. Now, Ainesh, again, you're not using the triangle properly. It's not 8. It's not 8 per se. What is it?
-8.
And what is the reason? Can you accept the reason?
Yeah, because it's below, so it's negative. Like the
Something like
coordinate
that.
will be
Like the coordinate.
minus.
The quadrant. Okay. Then the -8 will be super beneficial to you. Your setup is ready. Your
Wait,
setup is ready.
why
Yes.
is this here and not here?
Because they say reflex angle.
Oh,
Reflex angle. And your calculator will give you quadrant 1. Just like you asked. Hey, why not quadrant 1? The calculator will give you quadrant 1 without thinking too much because his program is not thinking. You can understand the reason why it's reflex 1. Cannot be quadrant 1.
True.
And therefore, you are now starting to be smarter than the calculator. That's the whole point, I suppose. Yeah. Okay, Michael, you're back. Now, Michael, tell me, can you draw the line or do you want some hint?
I can't draw the line. I know that when x is 0, y is 2, but that's
all right. All right. So let me give you some hint. Now, the 2 is the 2 here, correct? That's our first point, correct? This is 2. Now, I teach you my way of handling the gradient. Handling the gradient is super simple. The gradient currently is -8 over 3 pi. Remember, this is called the rise and this is called the run, correct?
Yeah.
So the rise is y-axis or x-axis, just to confirm?
It's y-axis.
Good, y-axis, and x-axis is the run. Wait, this is exactly what we have. In your y-axis, these are normal numbers, and in your x-axis, you have pi, correct or not? I mean, you don't have pi, but you're supposed to use pi. Correct or not?
Okay.
You currently have in your x-axis, just call this 2 pi, right? Correct? 4 pi and pi and everything, no? Correct?
Okay.
So we handle it like that. Look, my rise is 3 pi. Well, there you go. That's my 3 pi, correct? 3 pi is clear, correct? 3 pi. However, my rise is -8. What does -8 mean?
Goes down to
down. Right. 6, 3, 4, 5, 6. I call this -6, look, okay?
Yeah.
So to handle my gradient, I have this advantageous point, right? This is me doing rise -8 and run 3 pi, correct or not?
Yeah.
Did I fulfill my promise to you that the gradient turns out to be easy to handle?
Yeah.
All right. Now remember this for exam. Remember it because they are actually trying to make your life easy, not difficult. Okay. So Kyoko, you have your cosine, you have your sine, good, and you have your and that's fine. You're good. You're doing very well. So Ainesh. Oh yeah, let me see. Sorry, cosine positive, cosine. Yeah, good, and then sine, and then the sine B is negative. Excellent. Tell me the final fraction because I cannot read it. What is the final fraction? That's, oh my goodness, you did it wrongly. Oh. You read the formula wrongly. Let me get back to the formula. Page 1. Which page is this? Sorry. Page 1. Okay, let me show you how to read the formula. This is not your fault. This is sine A times cosine B. It's times. Sine A times cosine B, then plus cosine A times sine B. There's supposed to be times in the middle. Ainesh.
Yeah.
Yeah, so that's the only mistake you make. You fix that and then you'll be fine.
Times? Where's times?
One more time. In page 1, are you with me in page 1?
Yeah.
So this is sine A, page 1. Are you there?
Yeah.
Sine A times cosine B. It's not a plus.
Oh, okay.
And then cosine A times sine B. It's a formula. It's a memorization. We use it. Blah blah blah. Okay. No need to erase everything. Just do times. Okay. Yeah. I mean, do what you want. Okay, Kyoko. As you can tell, you found the answer. Look. Totally skipping the calculator, so to speak. Okay, Kyoko. Any question on this method? You're muted, sorry. You sure? Because you did it very well. You did it very well. This is the good feeling. This is the right feeling. It's the right feeling.
Yeah.
Okay, and you are skipping the weaknesses of the calculator. So as promised. Okay. Now, if you're comfortable, you go to page 4. Page 4, what you did just now is with calculator. You are now going to do it without the calculator and see whether you bypass the weakness or not. Okay?
Is that 77 by 85?
Excellent, Ainesh. You are absolutely correct. Is it positive or negative?
Positive.
You are also absolutely correct. Do you understand the feeling of this method? Kind of. Good. Did the method delivers on the promises?
Yeah.
What is the promise, by the way? Sorry.
That it doesn't rely on the calculator that much.
And therefore bypasses the weakness. Right? Because not relying on calculator doesn't sound like a very appealing until you realize calculator has weaknesses. Until you realize. Okay, good job. Now you go to page 4, simple question. Try and do it. Let's see whether you can do it correctly or not. Okay. You and Keiko did it first and you encounter the weakness of the calculator. Ugly number. Let's see whether you can bypass that calculator. Okay, Aryan, I think your drawing is very nice. The labeling of the x-axis, at least one, please. At least I want to see the period, the x-axis.
No.
Okay, so Mike, I think what you're drawing is it's reasonable. Why is the 3 pi over there? Sorry, I think your 3 pi, what?
Me?
No, Mike.
Oh, so
Huh? My 3 pi.
Yeah, because the run is 3 pi, right?
Yeah.
Why is your 3 pi there? Sorry, huh? Am I missing something here?
This
Oh,
my this is my run one, my 3 pi.
wait, what's the period of cosine to x? What's the period of cosine to x?
The period is all the way till 720.
That will be
Wait, no.
totally wrong. That will be
It's
totally wrong.
180.
Yes, which is pi. So your 3 pi got problem because your period got problem, no? And just fix the period. No need to redraw. Just fix the period. 180 is pi, and then you have to redraw your 3 pi, and then you have to redraw the pi. The rest is fine. Okay.
okay.
Okay. No, it's not 2 pi, Mike. It's 2 pi over 2, right? So pi, no? Correct or not? It's 2 pi over 2. So pi, lah. Correct or not?
Okay.
Okay, now I'm looking at your working. So it's
For part 2, do I ignore the line thing?
yeah, it's fine. Just ignore the line. You can answer it that way. It's fine. So because if they ask you this kind of question, I think they will ignore the line also. Then they just do it this way. Make sense?
Okay.
Okay. Ainesh, are you okay? Are you doing pi page 4?
Yeah. Page 4.
Yeah, page 4. A very simple question. The question that you did also, and you end up with not a nice number. Page 4.
So I use the method you just taught.
Yep. See whether it is superior than the calculator method lah. See lah.
Cos 4 by 7.
Okay, Kyoko. And you're done with side A, basically. Now, Kyoko, would you like to press the calculator and see whether that's close to minus 0.821? That's right. Yeah, is it close?
What?
Is this answer close to your first answer? Back then, your answer was minus 0.821.
Yeah.
Do you understand that this method is superior than the calculator method? This is the nice number they need. Yes, Inish?
Which quadrant do I put it in?
Oh, reflex. They tell you reflex. They won't tell you the quadrant one. So the 0.90 is our minus. They tell you it's reflex. They tell you it's reflex. So which quadrant?
The coordinates don't work because if it's reflex, right, then it should be -7.
Okay, wait. Reflex means either 3 or 4, correct? Correct? Either 3 or 4. So that's the confusion, correct?
You're
Correct.
cutting off.
Now am I in? Now am I in?
Can you repeat what you just said? You
Correct. So reflex means
Yeah.
third quadrant 3 or 4. That's the confusion, correct? Does that make sense? That's what reflex means. However, they are already telling you which quadrant implicitly by telling you that the cosine is positive. Remember that. If the cosine is positive, then I can choose between quadrant 3 or quadrant 4 properly. I can.
Yeah, it's quadrant 4. Okay.
Correct. Because in quadrant 3, cosine is negative. Meaning to say, if I put this as negative, then it should be quadrant 3, if that makes sense.
Yeah.
Okay, good. So Kyoko, just confirm that that answer is also what you did, 1.44, right? Okay. So the 3SF is totally not what they like in the A math, so you're just not gonna write that down.
Okay.
Understand it? So because they have an obsession with nice number, so they don't care. I don't care about that, something like that. Okay, it's for you. It's just for you to know that you're correct. No? Okay, right. Good job. Any question, Kyoko? Right. If you don't have a question, take a break for 5 minutes, and then we'll move on a little bit. Okay. Okay, Michael, I think now your 3 pi makes sense. Yeah, much more lah, much more. Okay, do you understand the question now?
Yeah.
Okay.
But
Yes.
I do part 2, but I just write 2.
Let me see. Yes, you do part 2, please. Part 2
But
is very likely in exam, I think.
But do I just write 2? There are 2 solutions.
Actually there are 2 solutions, but do you know, because they have this phrase, show your working clearly. They're actually looking for something. They're actually looking for something before they give you the 2 marks.
But what is 1, 2
Okay.
solutions?
Right. So let me repeat this. Your graph grants you the first 3 marks. I guess that makes sense, right?
Yeah.
Correct. But what this is the working they are looking for. Let me show this so that you will do this. You will do this. This is very similar to the E-math one. So when I'm teaching you this, I'm teaching you both A-math and E-math. Show it. Just show it to me. You will notice that this is not exactly this, and this is not exactly that. You will notice that.
Yeah.
I will make them the same. But what does that mean? So look. First, I will separate them.
Yeah.
Okay, and then I realize again, we are very close to this and we are very close to that. What do? I do, correct? Door times 3, correct?
Yeah.
So I will now have 3 cosine 2x equals to minus 8 over, in this case, pi. Oh my goodness, they did a mistake. Oh my goodness. Oh my goodness.
Yeah.
They did a typo. Oh my goodness, this 3 is not supposed to be there. Oh my goodness. The question is wrong. Okay, right. So by right at this stage, this is exactly the same as this, and this is exactly as that. Right?
This is supposed to have 1 solution.
I actually made actually maybe even 0. Actually, I don't know whether it's 1 or 0. Is it 1 or 2 or 0?
It's 1. Like
Probably.
Because this line says it intersects, but then I think if it's more was it accurately drawn, then this will be like a tangent.
Very difficult to guess. I would still say it's 2. You are currently gambling here. You're currently gambling. All right.
Yeah. Okay.
But this is the process of what they're looking for. They're looking for the 2 marks here. Look, this is showing. You know?
Okay.
When you do that, then you can legitimately use your graph lah, and then it's done.
So there's a typo.
I think so. I believe so. I'm gonna check later, but I believe so. I believe so. Okay.
Okay.
Right. Good job. Now, Inesh, let me see. Yeah. All right. So Inesh, your positive and negative, both negative are excellent. They hate the decimal, so don't write the decimal. When you have the nice number, the root and stuff, they call that nice. You don't have to write the decimal.
Okay.
Right?
So this is
You
that.
are, yeah. Now, did this method in this question, is the method still superior to the calculator?
Yeah.
Why is that so?
It's just easier, and it doesn't. It's easier.
It is easier. That means you understand. Good for you. But there is another superiority lah. What is it?
It fixes the first mistake that you caused.
No. It gives you the nice number they want.
Oh yeah. Yeah.
Meaning this minus root 33 over 7 to them is infinitely better than 0.821.
Mhm.
Right? That's the superiority. I guess that's how it is. Okay. You understand this method? Good. Take a break for 5 minutes and then we'll move on. Okay?
Okay.
Okay. So Noah, I'm looking. Yeah, okay, Noah. Noah, any questions so far?
Yeah,
Okay, tell me
No.
what's the question?
page
Page-
9. part
Page
C.
9. Okay, part C. Yeah. Oh, wow. Okay. Okay, so sometimes in trigonometry, there is a word problem, I suppose. Yeah. Now, what's your question?
How do I do it?
Okay. Okay. Now, I will tell you the method that makes more sense first. Okay, then maybe later on you can learn the short method. Now, to make sense out of it, you should draw this first. You should sketch this. Sketching this is not difficult for you. Would you please try that? Okay, so sketch it first. Aryan, any question?
Yeah, I'm not sure how to draw the tangent graph.
Wonderful. Now, first of all, fix your x-axis. It should be pi instead of degree. Do you know why?
Not.
Oh, you're very rusty. Because the way they tell you is that they don't tell you radian or degree, they tell you here. Correct? They tell you that. Look at that. 0 until pi. Page 8, right? Page 8. 0 until pi. They are telling
I still
you
can't
it's
see
radian.
the.
Sorry.
I still can't see the.
Oh, I'm sorry. You still, you can still cannot see the gene. Okay. In what?
I'm talking about the question in sent.
Oh, I'm so sorry. Oh my goodness. I'm so sorry. Right. Okay. I'm so sorry. So what's your problem again? Sorry. The tangent graph, right? Okay.
Graph, yeah.
Now, are you saying that you forget the tangent graph?
No, I'm just saying I'm not sure how to draw like a different type of tangent graph.
All right. Let's start from here. You should draw the tangent graph separately with a simple sketch first, nothing fancy. Right? In exam, that's the best way. So you draw the tangent graph separately. Let me just see. Just something simple to help you, right? If it is correct, then I will guide you to combine them. Yeah, very good. Does asymptote, please? The tangent graph should always draw asymptote first. If not, you're wrong, right? See, you're already wrong, right? See, okay, right. Okay, now tell me the period. Oh, your tangent graph is very bad, isn't it? Oh my goodness, right? I think you're forgetting your tangent graph. Okay, all right. Let's see how it is. Where's the period? Where's the degrees and everything?
Oh wait, the asymptote is supposed to be here.
No, your asymptote is correct. Your mistake is the middle guy should be 180. You're treating the asymptote as 1. No, it should be 2 things. You still cannot see the Jamboard? Oh, this is so bad. Have I shared with you? Yes, I'm sharing with Aryan Nikam 879. Am I correct?
Yeah.
Correct, yeah? Oh my goodness. Look, we cannot communicate very well here. Can you turn off your Jamboard and turn it on again and reload?
Yeah.
Okay, are you in?
Yeah, but I still can't see.
Open your other Jamboard. Let's see, the 2251 Jamboard. We go to page 18. Okay, can you go in that one?
Yeah.
Page 18. Yeah. Can you see something? Page 18, can you see anything?
Yeah, you drew a graph.
Yeah, okay, I drew the axis, right? So the problem is you're not being professional, Aryan. You're not professional. You didn't start with the scaling. That's your problem. Even though it's a simple sketch, start with the scaling. Okay, now here's your problem. See whether you can see your problem. Okay, you didn't start with the scaling and therefore it causes problem. Like that. There, that's your problem. Do you see your problem?
Oh,
Okay. Your scaling was off. Everything was off. Understand?
yeah.
Now, in terms of period, what's the period here?
That's 180.
No, that's not 180. You're absolutely wrong.
So sorry, 360. 360.
That's also wrong. It's supposed to be 360 over half, which is to say that's 720. This is originally your 180. That's why you say the period is 180. Now it's 180 over half equals to 360. Do you know why? Do you know why? Do you know why? Aryan, stop drawing. Do you know why? Do you know why this
Yeah,
is 360? Why?
Yeah, because it's 180 over half. Like it's half. It's
Why is it over half? Why?
because
Why?
in the equation it's tangent half x.
Yes. You understand this? You sure?
Yeah.
Now this is your sketch. You sketch this first. You're not getting a free one. I'm gonna erase that. Sketch this for yourself and then you combine. That is what you do in exam. Sketch it first. Sketch it properly. Mike, you okay? Michael, you okay?
I think.
Where are you?
so.
Where are you?
Question and
Question. Sorry, which page? Sorry, which page?
page 9.
Page 9. Oh, yeah. Okay, that thing will be difficult for the C1, right? So, do you have some drawing? No. Oh, there you go. Oh, very good. Okay, let me see that. I like your drawing very much. Oh, I like it. Okay, that's not 2 over A. Okay, that's 2. Oh, you're correct. Oh my goodness. No, you're correct. You're correct. You're absolutely. Oh, I love your drawing. I like it. I like it. Now, after you draw, I promise that it will be easier, right? Okay. Okay. So it is pulled back here, right? It is pulled back here. Correct. This is your 20, and this is your. Therefore, what is this? Let's put it by. Noah, Jamboard, page 9. This is 20, pull back 8. So where is this?
12.
12. So just make a prediction. You might not know exactly, but make a prediction. So if I pull back here, then I release, what will happen?
It goes back.
It goes back. But do I go back to 20? Is that what I'm doing?
Yeah.
No, I will go past one.
Oh.
That is the part that I think they leave it to you to figure out. So they actually go to where?
I don't know.
What is this? What is this? Oh, okay, never mind. I'm gonna say it's 28. So I'll just say that, okay, maybe you don't know the physics. So I tell you, this is 20, 28, and 18. Can?
Oh, okay.
Okay. And where do we start? Just to be clear, where do we start?
20.
No, we start at 12.
Oh,
Start at 12. Oh, yeah. No wonder this question is hard. So we start at 12 instead. Then we go like that. No? We go like that, correct? Something like that. Okay. Okay, so this already tells you what 28, 20, and 12 is like. That's only one, right? So the way you draw your graph is like that. However, the question actually goes from 12 to 20 to 28. So that tells you something about our graph. Our graph needs to flip a little bit. That's one. Okay. Secondly, this is 4 cycles per second, right? Do you understand what this means? So what's the period? No, the period is 1/4 seconds. You're mistaken. Because period is 1 cycle. So if it is 4 cycles per second, period is 1/4 seconds. So currently your 1/4 second is 2/a. So that means you got your A. If that makes sense.
oh, okay.
Right? And then the 12, 20, and 28 is supposed to help you find the B. It's supposed to do that.
Yeah.
Right, give it a try. Okay, Ainesh and Kyoko, let us start again. Ainesh, are you back? Ainesh, are you back? Kyoko, are you back?
Yes.
Kyoko? Okay, Kyoko, good. Ainesh, are you back?
Yeah, I'm back.
All right, okay. Kyoko, please turn on your video, yeah?
Okay.
We're going to go slightly forward and then we're going to end today. This is definitely advanced enough for Kyoko, and this is a very good start for Ainesh. Ainesh, your score will go through much more than this in term 3. So, but this is an excellent start. So where is the question? Okay, follow me to page 7, please. Kyoko and Ainesh, follow me to page 7. Are you there in page 7? Page 7?
Yeah.
Okay. Ainesh, are you with me? All right. Okay. Now, look at question B. You're going to ignore this one. Question B is the ultimate question they will ask you in terms of this kind of thing. Let's see how different or how similar it is. Tangent theta is reflect. Is this the same as the previous question? Kyoko? Kyoko?
What do you say?
Page 7, question. Given that theta is reflex, okay, so this part first, let's analyze the question. Is this similar to the previous question?
Yes.
Okay, good. This is similar. Now, how about this? Cosine theta equals to P. Ainesh, is this similar to the previous question or not? What is the difference, however? Similar, what's the difference?
It didn't give you what cosine theta is.
Well, it did give you, but what's the difference? He gives you.
Yeah,
what
it's not a number.
Is a P, right? Which is maybe very, very unnerving depending on how dark. So what the heck is this P, right? Similar, but but weird. Now, how about this one? P bigger than 0. Kyoko, is this similar to the previous question or not? Kyoko?
No.
It is. Very surprisingly, it is similar. Let me tell you what it means. It means P is positive. That's what he's telling you.
Okay.
Why is this similar to the previous question? Even though the middle one is so weird, I know. It means something like this. Ainesh, the theta, which quadrant?
it's positive, so it should be
Yeah.
this one. 4.
Oh, very good. Very good. He's telling you again that it is quadrant 4. If this is p smaller than 0, which quadrant, Ainesh?
3.
3. Do you understand how the question is telling you things, Kyoko?
Yeah.
All right. So start with this again, right? Sub. Look at how I handle the super weird thing. Look at this. Look at this. This is what I'm teaching you. Yeah. Cosine theta in quadrant 4 is equal to positive p over 1. Can I draw this over 1? Can I do that or not, Ainesh?
Yeah.
Can I do that, Kyoko?
Mm.
Okay, 1 positive p. Then root 1 square minus p square negative. There you go. Do you understand what I just did?
Yeah.
He give me p. Okay, lo, I make use of p. Lo. Doesn't matter whether p is a number or not. It does not matter. The method works fine. Now, express the following in terms of tangent theta. What is it, Kyoko? What is it? Kyoko?
Negative root 1 square minus p square over p.
Done. Do you understand? Kyoko and Ainesh.
Yeah.
I'm going to ignore this for now. Ignore it. Now, are you ready? If you're ready, I'll erase the question. I erase the answer, sorry. Are you ready? Ainesh and Kyoko, are you ready?
Means we redo the.
Oh, same thing. Redo. Same thing.
Okay.
Are you ready, Ainesh?
Okay.
Okay, erasing. I'll add to the question because you're ignoring part 2, right? I haven't teach you what that means, right? A lot of complication. I'll just ask you, what is sine 2 theta? Just to remind you, you will be needing the formula. Just remind you. Okay. So please do your tangent theta and your sine 2 theta. If you can do this, that's it. Very good progress. Michael, anything I can help you with?
Yeah.
Which page?
9.
Okay, right. Where are you?
Trying to figure out A.
Have to figure out. Okay, Aryan, your drawing is great. Your drawing is great for that one. Excellent. So moving on. Moving on. Try to figure out A. Okay, have you done B? Wait a minute. Have you done B?
No.
Why are you doing this in exam? Do
The second one first. Okay.
if there is a relationship with the first one, is there? Well, unfortunately, maybe not. Maybe not.
No, I don't see it.
Oh, this school is so nasty. No, the school is so nasty. The school is just nasty. Now, however, B means you can still solve it. Can you do B first? Okay, A is just 3 marks, okay? And it is annoyingly complicated. It's annoying complicated. It's not worth the 3 marks. Yes, Arya? You did the next one, is it? Sorry. Okay, Warren, you need the next one, correct? Okay, Aryan, I have sent you. Oh my goodness, this is so delaying. This is so delaying. Right. Okay, Ryan, I've sent you the new question.
Yeah.
Okay, give it a try. Try to experiment with the Jamboard after the tuition, yeah, because it is very delaying. Yeah, try afterwards. Okay. Kyoko, I think you're drawing something, correct? Ainesh, are you ready for the question?
But I got a question, but
Yes, no. Which one?
this year.
Still page 9? Still page 9, is it?
Yeah.
Okay, the A is 8. I totally agree with you. And then the B, show me the B. The B is 20. The 20 is fine. Yeah, I will agree with you. Fine. Okay, then your question is part 3, right? Find the duration of time in each cycle. So the object is more than 20 centimeters from the wall. Okay, now I'm gonna do this for you. Huh? So I'm gonna use your drawing instead. Huh? So something like that, right? So by now you know that this is 20, this is 28, and this is 12. By now you know, correct?
Yeah.
So 0 is way below here. So our initial drawing is not very accurate, but at least now you know. Can you?
Yeah.
Now his question, do you understand that his question means like this? This is 27, very close, right? Okay, can?
Yeah.
Then this guy and then this guy. So it's basically saying what is this and what is that. Basically, that's why he's asking.
Oh, okay.
Right, that is what he's asking. Now, I'm not sure how that will help you, but I really hope it helps you.
But
What you're doing is not wrong. It's not wrong per se, definitely not. But what do you do with the alpha? That's the important thing, you see.
Okay.
Like, what is alpha? Like, according to you, looking at the graph, what is alpha? What is alpha? According to you. In the graph, what is alpha?
Not sure.
The alpha should be this guy or what? No, that's the thing that I bothers me a bit, right? 27 will give you alpha. Look, your alpha currently here is 0.505. Okay.
Okay.
This is your 4, right? This is your 2 over 8, right? 2 over, yeah, this is your 1 over 4, right? Which doesn't make sense at all. Wait, I think 4. If this is 1/4, how can this be half? This doesn't make sense. Right, this doesn't make sense at all. What's going on here? Oh, because you haven't divided with 8 pi, my goodness. Okay, so this guy is 0.505 over 8 pi, correct?
Okay. But
Okay.
there isn't
Okay.
any fourth quadrant thing.
Oh, no, look, oh my goodness. Isn't this the first quadrant here? Look, first quadrant, right?
Oh.
And isn't this guy the fourth quadrant, for example? Correct or not?
Oh, okay.
Stop. What they're asking is not this guy. What they're asking is not this guy. What they're asking is this plus that. Do you understand? They're asking for this plus that. Can you accept that? The answer therefore will be, according to graph, is 2 times 0.505 over 8 pi. Something like that. That's the answer.
Okay.
Do you understand why it's 2 times that?
Yeah.
If you go and find this, you will be wasting your time, so to speak. And it's still wrong anyway. Okay.
Yep.
If you understand this, then this is probably the hardest trigonometry question they can ask you. This is already the hardest one. Enough hardness. Enough. Okay, good. So Kyoko, your sign, yeah, I agree with you, Kyoko. Good. Do you understand?
Yeah.
This is enough progress. This will be more than enough for your term 3. I'm not sure whether your term 3 will reach this one, but maybe it will, maybe it won't. I don't know. Okay.
Okay.
Good for you. Take a rest. Enjoy. I will see you on Sunday. I will send you the proper tuition schedule for normal week. Meaning this Sunday is already normal week. So it's going to be starting either this Sunday or this Monday. Because we haven't discussed the normal timing. Okay? Okay. We'll discuss using WhatsApp. Okay? Congratulations for finishing the holiday tuition. Right?
Yeah. Okay, bye-bye.
See you.
Bye-bye.
Bye-bye. Okay, Ainesh, I'm following you. Oh, now your drawing is very clear. Okay, now where's your P and oh yeah, great. Oh whoa, okay. According to the formula, Ainesh, sine 2 theta is 2 sine theta over times cosine theta. It's not 2 tangent theta. So the formula just says so. It's 2 sine theta, not 2 tangent theta, please. Now, I need to see your triangle properly. Your triangle, where's the P? Is there any P in the triangle?
Yeah.
Where's the P? And then what do you write in the hypotenuse, just to confirm? Okay, very good. Right, and then the sign. Why is your answer? Why does your answer have no minus, the final answer?
Oh yeah.
Is this all?
There should be a minus here, I think.
Okay, now let me test you one more time. Huh? Tell me what is sine theta?
Theta is this.
Yes. By 1. Very good. What is cosine theta? Just to confirm.
P by 1.
Very good. And what is tangent theta? Saying the positive, negative very clearly.
This, like the minus with it, this.
Over
P.
P. Very good. So the end result is negative or positive?
Of what?
Of tangent theta.
It's positive.
You just say negative over positive.
Oh, sorry. Yeah, negative.
Negative. You okay?
Yeah.
All right. This will be your first 30% of your 35, maybe 35% of trigonometry, right? It is very tough at the start. It will continuously become slightly easier, only slightly. I think you went through the peak already, I think. Let's see what happened, right? You are making it more difficult. Sorry, not your fault. Sorry. Your situation is more difficult simply because of your missed session in the first 2 times. It makes it like very confusing. You pull through somehow miraculously. Okay. Congratulations for finishing the holiday tuition. This is the end of holiday tuition. Whatever happens after this is going to be normal tuition. And I think I have a new timing for you. We'll just discuss through WhatsApp.
Okay.
Good job. And I will see you, Anish.
All right. Bye.
Bye-bye. Noah, any questions so far?
Next question.
Which
12.
one? You're doing integration now.
Yeah.
You can treat it as homework. You can treat it as homework, right?
But then ask what it means.
Sorry, you're saying?
What it means.
For now, you can stop already. This is the end of holiday tuition review. You can do it as a homework, right? Because you say, sorry.
I don't know what it means.
Which one? Oh, the question 12.
Yeah.
Okay, let me tell you. Question 12, does the question 12 gives you fx? Just to be clear, does it?
Yeah.
What does it give you? It gives you double differentiation, right? Which you're doing fine. You're finding the single differentiation. I agree. Then you go and find C, and then you move up, please. Move up. The way you find C is, I think, wrong.
Yeah.
When x equals to pi over 4, the f prime x is 0, not 1.
It makes C equals to 0.
And that's fine. No, that's fine. That's okay. No problem.
Okay.
C equals to 0 is a good news because you have to integrate one more time. Anyway.
But stationary point means the
dy dx equals 0?
So the dy dx of f prime x.
No. The stationary point of f. So f prime x equals to 0. That's why you're wrong.
Okay, I see.
Make sense? Huh? Nothing new, huh? Okay, 0. Then you can integrate one more time, and then you will get the f, and basically you are done with it.
Yeah.
Okay, give it a try. Aryan, are you okay?
Yeah.
You're stuck here? No.
No.
All right, give it a try. At least this one. Michael, where are you stuck? Tell me.
I am stuck at still question at page 9 part B
All right,
because
all right.
like okay, I did like all the things that I did for the previous similar question,
Yeah.
but I still I don't know if this step is even correct.
Right. Okay. Now, in this situation, it's not correct or not correct. It's more like useful or not useful. Of course, you can also do it wrongly, like, fair enough, right? Right. So my first question is not whether correct or not. My question is, do you think this the direction that you're thinking is useful?
Whether it's useful.
Because, for example, you split the tangent 2x into, I think sine 2x over cosine 2x, right? That's what you did, like. Same thing with the cotangent 2x. That's what you're trying to do. My question is it useful or not? That is the
So
I don't think so. But therefore, I think there is a better way, lah. I think, lah. Fair, yeah? I think, lah.
okay.
Okay, don't erase your method. Your method might be correct, but it might be too complicated. Now, listen to me. Cotangent to x is 1 over
1 cotangent 2x
is 1 over. Look, cotangent is not known just for cosine over sine. Of course, that's correct. I know, but
1
cotangent
over
is...
tangent 2x.
Yes. Do you understand my hint?
Okay.
Right. That might be a more useful direction, if you understand what I'm saying. Okay, so Aryan. Okay, Aryan, you are definitely rusty. So you are... Oh my goodness, you're missing 2 answers. Okay, so Aryan, you're missing 2 answers. That means you are correct, but you missed 2 answers. That's your rustiness coming in, right?
No, I'm still doing.
Please do. Good, Noah. Good. Following up. Yeah. Sorry, Noah, could you lift your hand? Sorry, I'm a bit suspicious.
Sorry?
I'm a bit suspicious. Oh no, you're correct. Sorry, you're correct. I thought you made them. What? Oh no. I thought you made a mistake. No, you're correct. You're correct. No, you're correct. Sorry. Please continue. Now, what are you supposed to do with that, Michael? First of all, it's supposed to be equal to 0. Don't forget that equal to 0, please.
Yeah.
Now, is this a good idea or am I misleading you? The question is basically, is it useful or not?
I think it can be useful.
How would you carry over? Because this is part of your rustiness kicking in. So if you derust here, that would be good. What will you do, right? What would you do here if you think this is useful?
Can I do this?
Not very useful. No, you can. Obviously, you can, but probably not what you want. Probably not.
So
Probably, I'm guessing.
Do I
Probably
want
not.
to factorize tangent?
It doesn't solve your 1 over tangent 2x problem. So the problem is tangent 2x and 1 over tangent. So I'm just gonna derust you, okay? I'm gonna let you try to see for yourself. You're gonna write let. Now, write let, please. Let tangent 2x be a different letter. What would that be for you? Okay, if you write it this way, can you solve it? I'm really trying my best not to tell you too much. What would you do here? Okay, Aryan, let me see. Your answer will be half. And are those 2 answers? Is that what you're saying?
No.
Okay. Oh, it's in radian. Okay, right. Okay, you're still missing 2 answers.
Yeah.
Michael, stop. You handled the... You did something wrong, lah. You did something wrong. Okay, just find the mistake first, please. Just find the mistake first. You did something wrong. Okay, that's not good. It's not good. This is not good. That's a careless mistake. You're very... No, that's not good. Find your mistake, please. The idea is correct, but you do it wrongly. Please find a mistake.
Sorry, I got a question.
Yes. Looks good to me. Yeah. You're supposed to find the C. Yeah.
What did they give to help me find C?
Oh, the one that you used wrongly just now. What did you use wrongly just now?
FX?
Yeah, you haven't used fx one. But the meaning is you haven't used one. Correct or not?
Yeah.
You tried to use one just now. It was wrong. It is 0, but that means you haven't used one.
Yeah.
Okay, so what do you do?
Is it the same thing when FX equals 1?
Well, when fx is equals to 1, what is x?
I will go.
Yeah, will that be useful?
I can plug that into FX.
Because it is fx equals to 1. Can you or can you not?
I can.
Yes, because it is fx.
Oh,
If that makes sense to you, make sense?
Yeah.
You see how well they hide things from you? If you
Yeah.
understand what I'm saying, they are hiding things from you and you have to figure it out. Oh, you figured out your mistake, Mike. Okay, good. Okay, Aryan. Okay, you at least have 2 answers. I'm happy with your second answer. You missed one more, Aryan. So this is your rustiness. Yeah? So let me tell you, and then we shall end here. So I will say your trigonometry a bit rusty, but also our Jamboard did kena delay lah. Which I cannot help you. My goodness. You cannot see the Jam. Okay, I'm gonna go. Oh, sorry, I have to go to your previous Jamboard, right? Previous Jamboard, page 18, right? Okay, Aryan, page 18. All right. So, okay, let me tell you your rustiness. Now remember this, yeah? Remember this for example. In solving question, I teach you, your teacher teach you. Do not cancel. Do not cancel. You are canceling the cosine x because you lose answer. Remember me or your teacher saying that?
Yeah.
Instead, what? I teach you more than just don't cancel. Instead of canceling, what do you do? Do you remember? Oh dear. Yeah, very, very rusty. Factorize. Okay, let me demonstrate to you. You are canceling the cosine x. No, I don't want. I want to factorize. Obviously, the cosine x lah, I factorize. What I want to cancel, I now factorize. Why is my first step like this? Why is my first step like this?
Oh, then you can factorize cosine x out.
Correct. If I don't put it at the same place, how can I factorize? Make sense?
Yeah.
Right. So now you do that lah. Now you do that. Now you continue using this method and see what it gives you lah. Okay. At least revise until this point. You are definitely a little bit. No, you're quite rusty. You're quite rusty. Okay, Michael. So you finally got something, and this. I'm not sure whether you're correct or not. Your answer is good. Sorry, your answer is what's your answer? Sorry, Mike, because it's very blurry. Sorry. What is your answer?
22.5.
22.5. And then 22.5 and then
157.5.
I think that doesn't make sense at all. I don't get why you would do that. Because you're currently tangent inverse, right? Why would you do that? Why would you do 180 minus 22.5?
Oh,
Is tangent what? Is tangent what?
wait, it's not 180.
Yeah, it's not. It's not.
It's
I mean,
135.
Huh?
No, wait. It's 90 plus 22.5.
It's quadrant what and what? Tangent is positive in quadrant 1 and quadrant 3, right?
Yeah.
Tangent is so Okay. Tangent inverse 1 is 45, correct?
Yeah.
You should have written 45 and the quadrant 3. What's the quadrant 3?
Quadrant 3 is
Quadrant 3 of 45 is... Quadrant 3 of 45 is... Oh, come on. Really, you're disgusting. Okay, we are running out of time already. 180 plus 45. Am I making any sense or not? No.
no.
Oh, you're very rusty. Okay, we run out of time. We're going to settle this on Sunday. Okay, settle this on Sunday. Just keep your working. Okay, right? Keep your
Okay.
working. Right. I'll see you on Sunday, Michael. All right, Noah.
Yeah.
Very satisfied, right? You got something and you got something according to the question, correct?
No.
The question is saying, oh, wow, you are correct, right? Excellent, Noah. Excellent. I mean, you got to a lot of the difficult questions. Good. Maybe you just want to try 11 as your homework. I'll see you on Sunday, okay?
Okay.
Yes, Aryan. So you're stuck here, right?
Yeah.
Look,
After
in this situation, because you factorize, right? Look at the other side. The other side is 0, and it is very important to be 0. Because, come on, a times b equals to 0. So, oh my goodness.
one of them should be 0.
No, yeah, one. So both low, so cosine x equals to 0, or that other guy equals to 0, correct?
Yeah.
So write it down quickly, write it down. Okay. Oh my goodness, you're rusty in many ways, isn't it? Cosine x equals to 0, that's what you're missing. Then the other guy equals to 0. Do you notice that the other guy will give you your previous answer?
Yeah.
All right, so your previous answer is correct, but you miss one guy, the cosine x. Okay, quickly, finish up, solve up. $1.57. Yeah. Where is it? 1.7. Sorry, huh? What? I thought this is pi over 2. No, is pi over 2 1.73? Really? Okay, how did you get the 1.73? That disturbed me a lot.
Oh, I accidentally put it like a different number. I mean,
okay, it's supposed to be pi over 2, 1.5. Just be careful. Okay, let's stop. Now, here's my last question. Do you ever understood the don't cancel but factorize principle in solving? Do you ever understand that? Think about it for a while.
yeah, I have understood that, but I just like couldn't remember it today.
You sure? Yeah? Because you seem to be stumped. It's more like if it is rusty, then you'll get back quickly. So next time, remember this, all right?
Yeah.
Now, obviously, you are still rusty, not just slow, obviously. Okay, definitely.
Yep.
Okay. Now, that's it. I'll see you on Sunday. Sunday is normal tuition, right? Normal tuition timing. But you try your Jamboard first, okay?
Yep.
All right. I'll see you. Good job. Bye.
Bye.